Hey, welcome here. My name is John Soward. This is Ben Greisler. You guys probably recognize him, but maybe not me, unless you went to Macworld many, many years ago. You may not have seen me do any presentations. We're going to talk about Proxmox today, and just to set some expectations, this is not a super deep dive into the internals and setting up anything wild and crazy. If you are a Proxmox expert and have been running this for years, please raise your hand. Shoot, I was hoping there'd be someone I could direct questions to, but I guess not. So this is going to be kind of an intro to it, what it does, and a demo of kind of how you might want to use it and what you could do with it. And one of the questions is, why are we talking about this at an Apple/Mac conference? And I can't answer that. I don't know why. When Ben asked me to make some presentations with him to come here, I put in a couple of things, ZFS, because I like ZFS and I've been using it since it first came out, and everybody seems to do it not quite right, so I thought that would be a great topic. But they didn't pick that when they picked this one, and this was the one that I was literally just sitting there trying to spin up for myself at the time, and I was like, well, if I have to talk about this, then I'll really have to learn it over the next couple of months and figure out how it works. And I had been interested in doing this because not so much for my day job, but for my side job, where I have some machines at a colo and host a variety of services for myself and other people. And I didn't want to upgrade that and just put it in the cloud, because to me, the cloud is just someone else's computer, and I don't want to be dependent on someone else's computer and someone else changing the rules or the prices or whatever. And that's just not as fun for me as running my own hardware. The traditional solution to go from what I had, which was a handful of individual servers, to a single cohesive system where you can move things around, would be something like VMware. But since the purchase by Broadcom, there's no free anything, and it's very expensive. And to be honest, I don't know how long it'll be around at this point. So I looked around for some other things, and things that might run on some cheaper hardware than a fairly expensive server. And so this was what I had kind of settled on, that I would at least try this out and experiment with it. And one of my servers in particular was about 14 years old, and it housed, a handful of websites and applications for people, but most importantly, my own Soward.net email, which I've ran since the early 90s. So the idea was I would build some experimental stuff, I would come here and talk about it, and then I would go home and build me a whole new system, and everything would be great. But unfortunately, it didn't really work out that way, because the week before I was supposed to come here, that was the time when the server decided it had had enough of being a server, and so I had to put up some temporary solution until I managed to get back. And I've used this slide before. It's very old. You can probably tell by the phone. Has anybody ever heard of a website called fark.com, F-A-R-K? So this is the software developer / system administrator for fark.com. He is from the same city I am, and their servers are literally in the next rack from mine at this same colo. And this was, in case you've never seen it, because you might not, their stuff's pretty reliable, but when their servers failed, this was what you got, was a picture of him on his kitchen floor with the server taken apart. So Proxmox, what exactly is it, and what does it consist of? If you go to their website, they offer three primary products: the virtual environment, a backup server, and a mail gateway. They've been around for a little while now, 2005, almost 20 years. And they're Austrian in nature, and so as such, there are standard kind of Germanisms in some of their software and their layout, but that's all fine. It's all open source, or at least semi-open source, with the AGPL Type 3, and they have free community-supported versions of everything, but they do want to make money on it. So they have paid subscriptions that you can acquire that gets you all the standard stuff: support, help, training options, but also kind of a different upgrade tray that has some vetted or custom configs and options that you may not get with the free versions. Their initial product back in 2005 was this mail gateway. And even though they call it a mail gateway, it does not like serve email. It's basically a fancy SMTP filter that can operate both in and out and does all the spam and virus kind of filtering stuff, but also allows you to do some fancy redirecting, domain redirection, and all of this sort of stuff. Their newest offering is this backup server, and the backups in their other environments, there's a built-in tool to make backups, but there's no built-in facility for organizing those backups or automating them. And the backups that you can do in the base products are all sort of disk backups. With this product, which also has a subscription, you can back up either to disk or to tape. And so that's kind of part of what the subscription is you've got to have drivers for the various tape robots and all of that sort of stuff that you may not get in the community edition. I haven't really messed with this, but I probably will eventually, at least to help me schedule stuff. The big product, the one we're going to talk about today, is their virtual environment. And it was the second one that they came up with, mostly to support their mail gateway, which needed to be scalable and redundant, reliable, etc. So they sort of built this product. And they also charge in sort of a per socket thing, but again, you don't necessarily need this depending on whether you're using this for experimentation, small office, or at scale. But either way, it's a fraction of the price of most of the competitors. From their website, they explain what it does in this way: open source server management platform for enterprise virtualization. Still don't know. I've been in IT since 1986. Still don't really know what the definition of enterprise is. You kind of have to guess. But it has most all of the kind of popular buzzwords. It can manage software-defined networks. Most importantly, it's high availability with the cluster support and has very extensive storage options in how it can connect and manage to existing storage solutions or build your own storage solutions. But what is it really? It's a set of open source packages that do all this, that they have configured in a way so that they work smoothly together, and then they've built a kind of wrapper of administrative tools around them, implemented as a set of REST APIs to control that. And if you don't know what a REST API is, that doesn't mean anything to you, but if you do, that might be helpful. But nonetheless, they use their own REST API to make a web-based management interface to control and manage all of these things from another buzzword that I really don't like that's been around in the industry forever, the proverbial single pane of glass. So you can connect to one thing and manage all of the machines in your system. Let's talk for a minute about what virtualization and virtual computing looks like in 2024. It looked a lot different 10 years ago and a lot different 10 years before that, and so on and so forth. If you've been around for a while, you may have seen the evolution and understand it. If you've not been around as long, you may be wondering how do we get to where we are now? So let's start with a short quiz about computer operating system level virtualization. Who invented that? Anybody have any ideas? Anybody want to shout out an answer? Nobody has any clue who invented virtualization? There's a few big players out there now. Maybe it was one of them, maybe not.
Guesses?
Somebody's got to guess. Very good. IBM. IBM actually invented the concept of virtualization. And they kind of took it and ran with it for a while, as IBM does, and then kind of went in a different direction, as IBM does, and some other people picked up on it. But when they were working on it, they established that there were going to be two types of hypervisors to control this virtualization. Type 1, where you would have your hardware, and then on top of that would sit this hypervisor, and you could have all of these different virtual machines all running on the same piece of hardware, but yet they were completely independent iterations of that. Type 2, slightly different. You could have your regular OS running directly on the hardware. It could run applications as it needed, but then you could also run a hypervisor and spin up virtual machines inside that were isolated both from each other and from the whole host OS and all of its applications. Pros and cons to each one, of course. And you think of something like VMware ESX as being type 1. You might look at some other server situations you've seen that were more like a type 2. If you're familiar with Microsoft's Hyper-V, you may think that it must be more like type 2 because you load Windows and then you enable Hyper-V. But really, it's more like type 1 because when you enable that, kind of behind the scenes, it actually installs a hypervisor and moves Windows, your existing install, into a VM. It's kind of crazy, but that's how it works. Since we had such good luck with the previous quiz, who do you think first used that term hypervisor as a way to describe that software that manages the virtualization? No other guesses? It was also IBM, but they actually coined that term not necessarily as part of that, but they used to like to use the term supervisor for all of their little software components. Well, this is the hard drive control supervisor. And so at some point they found that they needed a supervisor of supervisors, and they called it a hypervisor. So for bonus points, and in this round the points are factorial, so anybody could still win. When were these terms first used, hypervisor and visualization? We know they were IBM, so we know it wasn't last week, right? 60s? 60s is a good guess.
84.
So hypervisor was from the 50s, because remember, it wasn't necessarily tied to virtualization. It was just their internal software naming. And virtualization first appeared in 64. Somebody said the 60s, so they win. That's close enough. So none of these are new terms or concepts. They sort of, they were used with IBM's mainframe hardware in the 60s, 70s, and 80s, and then only started to really appear in more commodity hardware and mini computer style stuff in kind of the early 90s. There was a fellow that I worked with at the University of Kentucky, where I worked for 20 odd years, who was a real champion of the VM operating system on the mainframe, and he had a conference, and people would come in from all over the world to have us talk about that. I almost wore that T-shirt today, the 1991 version, because it's very Kentucky. It's got a guy riding a horse with a computer behind him, drinking some bourbon. So there's another kind of hypervisor that's what most things you might be familiar with today are, and that's the hybrid. And what that is it's more like a type 2, but there are direct calls through the host OS hypervisor system so that these VMs can have some amount of direct access to the hardware, and it's not limiting them in terms of speed. And there's a variety of different hybrid ones that are out there. These kind of best of both worlds, worst of both worlds kind of situation with it, but many of the ones that you would get today and ones that you might run on a desktop are really going to be these hybrids. The other big thing in virtualization right now, though, is containerization. And you are probably familiar with some of these terms. I've used Docker here, as that's the one that everybody has probably heard of, even if you're not into this sort of thing or don't do any of it as part of your job. But the idea here is that it's a lightweight sort of virtualization system. You can make a virtual entire machine, and it's great. You have complete isolation. You can maximize the use of your hardware by running a whole lot of lightweight things on one big piece of equipment. But you still have to maintain the entire operating system. You have to allocate resources for that entire operating system, and so on and so forth. With something like Docker, you can still get your kind of goal of isolating that particular application instance in terms of its user access, processes, meter out how much of the hardware it gets access to, etc. But you don't have to support that entire operating system. Docker, however, wasn't the first of these. The first sort of real implementation of this that kind of worked, that wasn't hardcore commercial, was jails in an operating system called FreeBSD. And you may or may not know a whole lot about FreeBSD, but ultimately FreeBSD powers a lot of Mac OS in a way, as that was what was adopted as the Unix layer in OS X when it first came out. These have a lot of advantages. I'm not going to read all of those off, but it's kind of a compare and contrast when it comes to choosing which one that you want. You know, you have a lightweight system over here that allows you to do most of the things that you might want to do in terms of isolation and convenience, but you are limited with containers in that they have to really be on the same kind of OS that your host is, because you're not running the whole OS. You're just running part of the OS and locking it down into a change-rooted C-group process-controlled environment so that it can't get out with some virtual disk access. So you can't do everything that you might want to do, but what you can do with a lot greater efficiency. You may have also heard of Kubernetes, or as many people call it, Kates. And if you didn't know why they were the same, that's why. Kubernetes is a K, 8 other random letters, and then the letter S, so it's easier to abbreviate that as Kates. All of these things have their sort of own priority of what they were going to be for. Docker, when they came around, they targeted developers, really. They wanted to make environments that developers could both quickly develop their software on their laptop. Maybe they were writing some Linux server software but had a Mac or a Windows laptop. You could spin up that environment right here on your machine without having to spin up the whole OS, build your piece, and then distribute it to other developers as a small package that would just install the pieces it needed inside its little realm. The other Linux-based containerization system, LXC, is a little bit heavier weight than Docker. Originally, Docker was built on top of LXC, but it split off after the first couple of years because Docker wanted something even lighter weight and to be able to write it in Go instead of C, which LXC was written in. The big difference between those two is that LXC, you can actually run a different kernel version, different Linux kernel version inside your container, and it will pass through an emulation layer down to the kernel version that's running on the host, whereas Docker, being a little bit lighter weight, doesn't allow you to do that. Kates, on the other hand, is somewhat agnostic to how you're running the containers from a top-level design, and is instead really built to help you orchestrate hundreds or thousands of containers across tens or hundreds of different individual pieces of host hardware. It lets you do that in a sort of semi-declarative fashion. It lets you dynamically launch and stop the different containers, and is really kind of an automation tool that was originally developed by Google. It's a little bit outside of the scope of what we're talking about here today with Proxmox, but as you investigate this for your own use, you'll see a lot of references to Kates, Kubernetes, Helm charts, etc. Proxmox itself doesn't actually support Docker as a native thing. It uses LXC containers for its containerization layer. But there may be the occasion that you want to spin this up and you want or need to use Docker, because Docker does provide a different layer, maybe a better layer, I don't know, it's arguable, of configurability and automation to start up and modify your containers. The containers are a little bit more portable because you have that standardization layer that they provide. But the real thing is there's a whole bunch of pre-built Docker containers that you can just fetch and install that already have the basics of what you might want to be using out there. And there are even some tools that you can only get as either a Docker container or maybe a Helm chart. And two of the examples are two of the things that I wanted to run on this new thing that I was trying to build. And I guess I will still go back and try and build. And one of those is frigate.video. If you're not familiar with that, it's an open source NVR, network video recorder, for things like security cameras that has some built-in AI tools for object recognition, etc. And then MailU.io is a comprehensive open source package that's also, like Proxmox, a wrapper around a bunch of open source tools, but this time to provide a mail cluster so that you can do all the things you might want to do with email, send, receive, have a web interface, manage users, filter spam, etc. And all of those things have sort of a Docker easy button that you might want to have on Proxmox. You can still use Docker with Proxmox. It's just not their built-in default for containerization. There's a couple of options you can do. To make it work, you could just install Docker on the Proxmox host. It is just a Linux box after all, and then you could just run Docker in it. But as the slide suggests, that's probably not the right way to do it, because this is meant to be an appliance level piece, so you install something in the host, it doesn't know about it, some operating system upgrade occurs when you upgrade your Proxmox to fix a security issue, for example, and it will damage or destroy your Docker. Also, it has no way to monitor the resource usage of that Docker running on the host, so you look at your one pane of glass and it looks like everything is fine, but it's not, because something's gone wrong there. The other options are to run Docker in an LXC container or to run it in a VM. And you can spend many hours online reading about why each one of those is either the only way to do it or the way you should absolutely never do it. But what it comes down to is, what are you doing with your whole setup, your whole Proxmox cluster, and what are you doing in that Docker container that you're going to run in one of those two on those two slots. It's still not going to be directly managed from the UI or the REST API, but it will be inside something that is, and thus a little easier to manage. Kubernetes, however, if you want to run that, you have a couple of options. You can just erase your Proxmox install and install a different thing called Rancher, which is made to do that, and only that, and that's probably your best option. If you just want to experiment with it, though, and have a Proxmox setup already going and need the VMs for something else, for example, you can just put it in a VM, because they are VMs, and you'll probably really be running K3s, which is Kubernetes Lite. If you're into reading about those and learning about them, just beware that, especially if you go to the Rancher site, because it's their project, there's a K0s, and you pretty much don't want that. That is a more special purpose thing. If you are developing like an IoT type appliance, maybe that is what you need, otherwise not so much. So just getting more into what it actually does, what it looks like, etc. It's basically a web view that is, I'm not going to say it's super dated, but it's a very traditional layout and design that is a little busy. It's not the simplest and cleanest, but it's fairly understandable to anyone who's been working with these sort of things for a while. You have, it's a little bit difficult to see here, on your left-hand side you have a data center. Even if you only have one node, that's the way it comes up. You have your data center, and then underneath it, all the nodes in that data center. The menu immediately to the right of that is context sensitive. So depending on what you have selected on this pane, you will have some different options over here, some overlap between them, but for the most part, those all make sense if you read what they are and look at it and just click through it a few times. We'll do a demo here shortly. Once you have this installed, in order to do anything with it, you need to first bring in some resources to your system. If you want to create some VMs, you need to preload the ISO that you want to use into Proxmox. And this is a little bit different. If you're familiar with vSphere, ESX, you could map one directly from the PC or laptop you are on to there and install it. And that's just not how this works. You load it to one of your nodes, and then you can build a VM from it once it's up there. Likewise, the containers, there are a myriad of pre-built templates for LXC containers, and it will actually go and fetch some of those for you from the server, but you need to initiate that first before you try and create a container. let's contemplate switching over to a demo now. I made slides for those that may be download these at some point of all of the steps for most of the demos in the event that this high quality demo rig I've brought here didn't make it or didn't manage to work. But I think it's going to work. So let's give it a go. The only problem with demoing this is that it is going to be a little tiny, so it may be a little bit difficult to see. So before we just break into the demo straight up, let me explain what the demo hardware is here. This is some very elusive and difficult to find equipment. I have a, I don't even know what it is, a 7 or 8 year old Mac Mini. I have a mini PC from the brand I'm sure everyone is familiar with called TexWho that I carefully picked out from AliExpress a few months ago, and I've got $200 odd in that, so it's very valuable. And then I also have another one I bought from Amazon. This is the Ace Magician brand of plastic and metal box, and together I have built a little cluster out of these. Each one has some amount of internal storage that came with it and 2 terabytes of external SSD hooked up in various haphazard ways. These all have 2.5 gigabit networking built in, and I have this very expensive $40 one-lay switch here that they're all connected to. Unfortunately, the Mac did not have that, so I had to get this high-priced Faircabe brand 2.5 gigabit adapter. Now, I'm not suggesting you use this in high-end production, but for a home lab or a test system, one of the things that's great about Proxmox is because it's just based on Debian Linux, virtually any hardware you throw at it, it will work with. And you can take some fairly inexpensive hardware and build up something that's fairly powerful. And as we will see, you can leverage the cluster component and the high availability tools so that even though this may not seem like the most reliable equipment in the world, it doesn't necessarily have to be, because there's reliability built in at the software layer.
So let me just jump in for 1 second. When we moved this from John's room, where John put it all together, make sure everything was working, we're like, okay, how are we going to carry it here? So literally, as it sat there, we dumped it into a bag,
Slide it off the table.
brought it here, dumped it back out onto the table. But interesting fact, just in case you ever need to MacGyver something, as we're putting everything together the other day, John goes, would you believe the one thing that I forgot was the power cord for the Mac Mini? And we're like, we'll figure this out, no problem. So just in case you run into this situation, the power cord for the TVs here will work in a Mac Mini.
Right in there.
And so problem solved, but then we found another power supply.
Yeah,
that
eventually
we were
we
able
found one that was more portable, because
so-
couldn't move that giant furniture in the room to get it unplugged from the wall anyway. But it worked out in a pinch. So it was durable enough to make it, on the airplane from Kentucky to here, and then from the hotel room down to here. And for now, it seems to still work. So what I've got here are these 3 machines. I've got this, some 6-core i5 Mac Mini. I've got an 8-core Ryzen 7, which is the TexWho, and then I've got a 4-core, it's like an N97 or something up here on the top, each with their own little 2 terabytes of storage. If you can manage to see it on there, maybe I can zoom in a little bit. So I've got the data center, which I didn't rename, it just has a name in parentheses. And you can see all of these 3 high-performance systems listed underneath it. The list of items over here changes. So I have this, I can see the status of all of my things. I can click on an individual item, and now if I go to the summary, it shows what's going on the Ace Magician with its 4 CPUs, and you have plenty of monitoring items. Let me get rid of this task list here. You can see everything moving around. Same thing over here. We got 6 CPUs, and actually I have 16 CPUs on this guy because it has hyper-threading. So you can easily manage each machine from the single pane of glass. And what that means in this situation is, right now in this web browser, I am connected locally to, it looks like the text who in the middle, but I can switch over here and be connected to, let's see which one this is. Here is, this is the Mac Mini. So I'm connected to the Mac Mini, but you can only really tell that by your URL up here. The view from each one is exactly the same. You can do anything from any one of them as long as they're working, and it's kind of as simple as that. Let's do a couple of demos while we're here. Let's go to the, let's go back to the TextWho, because it is the fastest one and already zoomed in. And let's create a VM. Just click Create VM, and you fill in a few things about it. You can, again, from anyone, you can pick any place that you want to create it. We'll go ahead and keep it over here. We'll give it a name, Demo 1. We'll pick some sort of ISO for it to boot from. Now, I've already put a few in here because you have to load a few before you can get going. We'll go ahead and do this FreeBSD install because I'm still a big fan of FreeBSD. This is all fine to start out with. We'll let it go ahead and create a disk here, but we're going to put it somewhere different. I'm going to pick a storage thing here. I'll talk about the storage ramifications and options momentarily, but for now I'm just going to pick pool 1, and one CPU is fine, and however much memory the default is will be fine, and this will equally be fine for the network. Just going to use a bridge device, so it's just going to emulate a network and then bridge it out as though it were a tiny hub over here. I can review all those before I begin, and then I'm going to finish it. And you can see it starting to work down here. It's made a little entry, but has a little unknown question mark status on it. It will be working away, and now it has made it. And we can click on it. When you want to view an individual VM in Proxmox, you can click on it. You can get a summary of what it is and how it's working and how you've configured it. You can look at its virtual hardware and modify those as needed. You can make a backup of it. I could just click this button and pick a place. It's going to make a snapshot, and off we go. It will only take a few seconds. I can replicate it. I can take a snapshot. All the things that if you've used vSphere or similar, you might be familiar with. But let's go to the embedded console, and let's start the VM. It will take it a few minutes, but it will come up with a little BIOS and then the FreeBSD installer for those that may have ever done that now or in the past. It's not much different. And it will install this we can go through these menus. We'll just...
and the fan kicked in.
Yeah, so it's really...
There's lots of blinking lights and the fan kicked in.
Really running here. We'll go ahead and do a ZFS root. It'll figure that out momentarily.
Who's going to get ZFS into this one way or the other?
One way or the other.
Yeah.
There's more ZFS to come still. And we'll make sure it selects the disk. We'll erase the disk. And we'll let it spit up. It shouldn't take but a minute or two to complete and install this. And you don't have to sit here and watch it. You could be going off onto other parts of your glass and get out glass cleaner or scratch it or whatever you want to do with all your other machines while you're out here. And
actually, I'll take that opportunity to explain why I was interested when John made the suggestion to do the Proxmox thing, because tomorrow I'm going to be doing a presentation on optimizing DNS. And if you wanted to run caching servers or your own DNS authoritative servers, or just local DNS or something like that, this is like the perfect type of environment to spin up a bunch of stuff like that, be able to distribute it, manage it, and such. So I saw this as a pretty good tie-in as an example of this is a good, legitimate, and available way to provide the other services. So.
I'll just configure the network manually here.
Has
This
anybody here
is
actually
awesome.
worked with Proxmox before? Okay. Anything that's popping up in your mind right now that, we can, set to the side and answer later, or anything along those lines?
Clustering. Just the moment you can actually run OS X in Proxmox. There are some ingenious people that have actually got Git repositories that show you how to run OS X on and off Apple hardware.
Should we throw this
Well, we can
back
probably
there?
just, until we take like full Q&A, we can probably just, yeah. And anyway,
repeat
we
whatever he
haven't-
said.
So while John's doing that and we figure out, do you know there's actually instructions on the bottom of the catch box thing? We should have actually had like a safety conversation before using that. So you were saying RSX?
No, so there are Git repos that will show you how to run Mac OS X.
Oh, there are repos to show you how to run OS 10, Mac OS in this. So that's pretty cool.
Yeah, there
Thank you.
absolutely are. That, it's a license violation, so I didn't want to talk about it or demo it here, but you can absolutely do that for now.
You do it if it's on a Mac hardware.
Yeah,
Yeah, maybe. Yeah,
The way that they do it is still, it's basically a hackintosh, though.
exactly.
sure.
Exactly.
It is on Mac.
Even if it is on Mac, yeah. James?
Speaking of the Mac, I mean, what have you got running on, I see you have various types of hardware. What's running on the Mac?
Oh, okay, so the question is on this Mac right here, what is running on it natively? And what's running on it natively is just Proxmox. There's no Mac OS on it whatsoever, just installed the Proxmox directly and kind of took off from there. And we'll see how that works. If we have enough time, I'll do a partial install and you can kind of see how the build goes. So now we have our guest. I shut it down and it's kind of ready to go. If we fire it up, it will boot and work, but it still has, if you look over here in the hardware, it still has this ISO attached as a DVD drive. So we're going to remove that because we don't want it to keep trying to boot from that every time. Now we can go back and fire this thing up and it will just log in and work after a few moments. And nothing that you haven't seen before. But what we can do with it now is if we have, and we do, more than one node available, we built this one on the TextWho, but we could move it somewhere else. So there's this cool migrate button right here. We can click that button and we can pick any of these other nodes to migrate it to. And the interesting thing about this is if we log in here, we can maybe ping one of the other hosts on our little network. As an example, we could maybe ping that guy as well. You'll never be able to see that. This will be good enough. So we'll click the migrate button. We'll move it to the Ace Magician, for example. We'll click the migrate button. It's going to give us the progress here, but you don't have to watch that. It will pop up down here. And so now nothing happened. I mean, it physically moved from one device to the other. You can see here that it moved, but it didn't miss any pings. Everything was smooth. If you were pinging this from an external site, maybe you'd see a little bit longer delay when it actually made the jump. But just like vMotion, it's moving not only the files, but it's moving the contents of memory and then just restarting it really quickly behind the scenes. You don't know what happened at all. So that is, even without firing up high availability, that's just two completely separate nodes. It's moving that data over this network between them. If we were to go back to TextWho, we can also create a container. Creating a container is almost the exact same in terms of the steps you go through, but you need some different material up front and a little bit different configuration. One of the first things that you have to do is you have to set the root or admin password as part of setting the container, because in a VM, you're going to load a different OS. It's going to have its own user management system. But in here, the containers, you need to have a way to get into that container as an admin when you build it. So you provide an initial password, or you can provide an SSH public key here as well. Kind of move on through here. And then here's where you have to have the templates loaded. And I'll try and do a demo of showing you how you can get these. I don't want to try and fetch one on the network here, but you can have some preloaded. I've pulled in a few. I'm going to do this one just because it's the smallest and will be the quickest, but anyone will work. Same sort of deal. You give it some amount of storage. You give it a place to put that storage. You can define how many cores you want to give it, as well as how you want to manage those, allocate whatever memory for it, and slightly different options when it comes to networking, because you don't necessarily have to virtualize the entire stack, but if you're a container, you may be able to take advantage of some custom networking that you've built in your host, like bonded Ethernets or whatever. I'm not going to do any of that. I'm just going to give it something here. And you have to specify the net mask here in CIDR notation, which is common in most things now, but it won't let you proceed if you don't give it a bit mask. We don't need DNS, and we'll
Save
go
that
ahead
for
and
tomorrow.
build this, and off we go. So you see, it made that thing in like less than a second, even on this high-end hardware. You know, what your super micro stuff at home may not go quite as fast, but you get the idea. So now we have it, and we can do the same sort of thing and start it up. It will spin up over here, and you see it didn't have to boot an OS, so it's just immediately available. I can log in with the password I gave it, and off we go. And it is also available to network, and you can do the same thing with it. We can migrate it. We're going to migrate it down to the Mac, and same sort of process. We don't need to watch the whole thing this time. It takes a little bit less time because you're moving a little bit less data and there's a little bit less going on. But same thing now, as you can see, it's on the Mac. And the only difference is this wasn't completely transparent. So this basically restarted, because when it was a VM, we could capture all of the memory and then restart that, push that over to the other node, restart it, and off you go. And it didn't have to shut down and restart. But with the container, since the memory is just interspersed with all of the memory on the host, you can't do that. It can't easily find all of those pieces of memory and put them back in the exact same spot as they were on another host. So the container will restart. So while you can do sort of high availability and you can do migrations of containers, know that it does imply that the container restarts. If you need something to be 100% up all the time, can't be down, can't restart, then a VM is probably your pony instead of a container. Let's go back to the slides for a minute before we talk about storage and some of the different storage options. Where am I at? And in particular, let's go down to here.
Mirror. Oh, there we go. Okay.
So there are a bunch of containers that kind of, they don't come with Proxmox, but when you go to download containers, there's a list of ones that it automatically fetches, and you can just click on them and say, go get them. And it's quite extensive. There's, 100 plus. But you can go to linuxcontainers.org and read all about LXC, but images.linuxcontainers.org has another list that you can use that are more complicated containers. You can't immediately import these. It will require a little bit of command line fiddling because these come in a different format than what Proxmox processes internally, but know that you can use them. And ISOs, there's a, can't really do this demo because the ISO would take too long to download. With the ISOs, you can simply go to any site that you want to. Oh, I want to go to TrueNAS and get a copy of that. Just go to the download link, but copy that link, then go back to your Proxmox, and where in your ISO selection, say that you want to download it. Type in the URL or paste in the URL. Click this query URL button, and then it will make sure that it can get it and understands what it is, and then it will fetch it directly, so you don't have to pull it down to your laptop or workstation and then push it back up to the service. So while it's seemingly not as convenient as some of the things that VMware had where you could just load it from your client, it's usually much faster, especially if your servers are at a colo somewhere that maybe has 10 gig or faster link. You're not bringing it all the way to wherever you are on Wi-Fi and then pushing it all the way back up to them. Let's talk about storage for a little bit. Proxmox offers an insane variety of different types of storage that you can use, but all storage breaks down into two primary categories: file level storage and block level storage. And of course, Proxmox supports both types and uses them in two different ways. In file storage, you can store any type of Proxmox data. You can store your VM images, your container images, the ISOs, the templates, local files, config files, backup files. All of the things can be stored. Block storage, however, you can only store images for the most part and a few other special things. You can't store backups, you can't store ISOs, you can't store templates. What that effectively means is that every node needs to have some amount of file store and then some amount of block store if you want to participate in a cluster. There are a variety of types of each one that you can use. All the normal block store things you might be familiar with are supported under Linux, the LVM stuff, iSCSI. ZFS, if you note, ZFS is on both sections over there. ZFS is sort of unique in that ZFS itself provides a file store that sits on top of its own custom block store. So you can spin up ZFS and have both of those options at one time. And Proxmox can put files on the file store part and then put things that are better served on the block store, like the VM images, on the other fairly transparently. The one thing that they also have is this Ceph. And Ceph is a clustered file system that we'll talk about in a minute, and that is kind of key to enabling high availability in a Proxmox system. We're going to skip over this because we actually did the demo of it. These are sort of my backups in case we couldn't get this to work. You could at least still see what all happened. Somewhere in here we switch over to Ceph. There was one of these slides, yeah, this one, that I did want to show. If you forget that step where I removed the DVD and then try to migrate your VM, you'll get an error message like this, or similar, can't migrate VM with a local CD. That ISO image was downloaded just to this TextWho on its local file system, so it wouldn't be able to migrate it because it didn't have a way to get that over to one of the other devices because it wasn't a block store based item. So you're going to get an error like that and just go in and remove it, and off you go. Ceph, anybody familiar with Ceph at all? A handful of you? Anybody used it outside of Proxmox, just like on your own? Okay, at least one person. So Ceph, it's been around for a while, and kind of Ceph and Gluster and a couple of others are kind of big in the kind of high performance computing cluster world. And they all have their own, supporters and detractors and pros and cons and what have you. But the idea is that it is a cluster file system that is highly redundant and fully distributed. Anybody in here ever use Xsan from Apple? Okay, so we have some Xsan people. So I'm not going to say it's just like Xsan because it's absolutely not. But if you're familiar with the concepts of Xsan, it's very similar in top-level macro design. But it does split it out in a more clearly delineated fashion because it's a little newer than Xsan and what Xsan came from. So it has a block layer that is the core distributed layer where every part of your cluster lives on every machine. Every machine proffers up some amount of storage to join in that cluster, and then you as the admin can specify what level of redundancy do you want. And what that means is if you've got just the 3 machines here, I've got some amount of storage on each one, and I can say, well, I need to have at least 2 copies of all of my data. So if I had, 1 terabyte on each one of these, that means the cluster size would be only 1 terabyte because I've got to have 2 copies plus itself, which is 3. So I'm only going to get 1/3 of that storage. But it also means that any 2 of these nodes could fail, either their drive or the entire node. I've still got my stuff. The second one could fail. I've still got my stuff. Only when the entire operation is down would it be gone. There's also the Ceph file system, which sits on top of the Ceph block system, and that is more like those that are familiar with Xsan, more like what you had with Xsan, in that you have metadata controllers that need to have so many running, and it has a whole caching layer. That is fine. You can totally use that here, and you can use that in a variety of different ways, but really, if you're just using this for a high availability cluster of VMs and containers, all you need is the block storage device. Hence the vaguely Xsan-like. A couple of terms you'll see when you read the docs is that RADOS, which is just their term for a reliable distributed object store, and then the actual object stored device. Because the question that I had and a couple of friends of mine that were trying to work through this at the same time I were like, all right, well, I installed the Ceph and I got the Ceph working, but there's no place to put any storage. So we'll explain what that is and how you have to go through an extra step to get that. Just to install Ceph, if you just click on Ceph in the menu, it will immediately present you with this screen. It's not installed, would you like to install it? And a lot of people get stalled out right here because you'll come to a screen and underneath this drop down is a button that says install, but you'll click it and you'll just get an error that says you can't log into something somewhere, Proxmox. Oh no, what's going to happen? And what that means is that you don't have an enterprise subscription because that is its default. And their, I guess, hope is you'll just go ahead and buy one and carry on. But all you got to do is pull down and say no subscription, and then click continue, and they're basically just shelling out to the apt command and showing you the contents in a web view, and you'll install all the pieces and take off. The next bit of the configuration is where you tell it what network you want the Ceph cluster to use for its data store. And this is where a setup like this is probably not what you want. What you would want here is you would want a dedicated network, just like we had with Xsan, for this data to flow onto. You could take this, all these machines have multiple connectors, and use this, and this would be good, but then just use the other connection for your actual external network and all the connectivity to that so that it doesn't impede the flow of data here. You also want this to go as fast as possible because the raw I/O speed of your Ceph is always limited to whatever the network speed of this connection is. So you could have the greatest, fastest, PCIe 5 4-lane SSD in here, and if you've got a 1 gigabit link, then you're only going to get 1 gigabit worth of speed out of your file system, even on that machine. Because when it goes to write anything out or read anything in, it's got to make all of those copies and send it to all those copies. And even when you're just reading, it's got to read it from another copy and make sure it matches and isn't corrupt. So that is key to your speed. You need that to go as fast as it can possibly go in order to maximize your performance. Hence this extra expensive 2.5 gigabit switch that I've used here. Once you have created that, it will look like it's working, but you need to actually attach your physical storage to it. So then you simply click on the OSD tab and select from the pull down which devices that you want to use. And this is a simple UI, but it's kind of confusing because you have to remember where the device you want to use was. So I find I always have to remember to go back to the disk configuration first and go, oh, I don't want to accidentally give it my boot disk or the disk that I'm trying to keep my other data on or my ISOs on, etc., and make sure I click the right one. Once you have that in there, then you'll have some available storage. It still won't really become available until you have enough of them online that it matches what you configured as the redundancy level that you wanted. So if you said you wanted a redundancy level of 3, until you have the third node contribute some storage, it won't show that you have any storage. When you install Ceph, you have that pull down and you can choose the no subscription. But sort of changing topics briefly, if you want to just update Proxmox and you go to the updates tab, you'll get kind of the same error when you try and update. It's a little bit harder here to get rid of the subscription option, but basically you'll just flow in here, remove or disable all of the subscription pieces, and then click the add button that's cut off at the top there and add the no subscription option, and you'll be ready to go. For those that are Linux friendly already, this comes as a bare metal installer, which is what I used on this Mac, in that it's going to wipe out everything and lay itself down. And it is a custom copy of Debian that they have modified, and they'll put all their software on top of that, and off you go. If, however, you want to install Debian yourself, and maybe you need a newer update train, maybe you need some custom drivers that they don't have that's going to confuse their operation or that you'd have to manually install, you could build Debian, and they do also make a package where you can just layer the Proxmox stuff over a generic Debian install. I'll skip over most of the networking. I'll show a quick demo. I think we'll have time. Basically, they support everything that Linux supports directly with both a command line tool, the API, and graphically you can, their default setup is all the interfaces are virtual. They're all just plugged in, and it just allocates one virtual one and maps it through to the first Ethernet device, but you can manipulate that however you want. I will do a demo of snapshots as well. They differ only slightly from backups, and it sort of depends on whether you're trying to snapshot a VM or a container as to how important those are. We can do a demo of this too, but the backup utility works well. It takes a live backup of either one, relies on a few tools in the back that we'll mention shortly, does so fairly quickly, but although it's nice, there's not a vast amount of automation configuration, so it's a good tool, but you kind of need to develop your own procedure around it or use their other product, the backup tool. So let's talk about the cluster bit a little bit more. When you're setting up your cluster of computers, the main things that you want to get are the ability to migrate and move your stuff back and forth, and possibly the high availability part. You can move, as we've seen, you can move your VMs and your containers, but you can't easily move your other file stores that you have, like existing backup copies, snapshots, the ISOs, the templates. Those kind of need to be downloaded immediately. They say in their docs that this migration of live VMs and containers is only guaranteed to work between CPUs of the same vendor. And since right now, production Proxmox only works on AMD 64 CPUs, they obviously mean AMD/Intel. That said, these are clearly two different kinds, and you just watched me migrate between two of them with no issues. But there must be something to it because they claim that it's only guaranteed to work between those. The other point I wanted to make here was about smaller clusters. The way virtually any clustering system that I've ever used works with is you have to have some way to determine who is actively participating in the cluster and who is not, who is down or offline or being removed. And that's usually done with the concept of a quorum. There's other words that are used sometimes, but they use corosync, and quorum is the term that it uses. And the way they've got it set up is you have to have more than 50% of the computers online to have a quorum. When you don't have a quorum, you don't have a cluster anymore, and nothing will work. Doesn't matter if you have 40 machines, if 20 of them go down, you've still got 20 working machines, but now you no longer have a quorum, so you have no cluster. If you have a big cluster like that, like we used to have last time I worked there at the university, and you had 500 machines, the odds of if 250 of them went down, we've got bigger problems than our research supercomputer. But if you have a cluster like this with 3 nodes, then you don't really have to lose that many before you no longer have 50%. You take down 1, okay, take down 2, oh, no, now the third one is like off floating in the breeze. If you get into that situation and you need to recover from it, you can, but you'll have to SSH in and run these commands here to basically take it out of cluster mode temporarily and remove the other 2 nodes from the cluster. To join new computers to your cluster, they basically just need to be able to get to each other on some kind of network. Obviously, would probably be less than ideal to do this over the internet, but technically possible as long as all of these associated ports are here. One kind of caveat, probably should have put an asterisk by it, is changing the host names after joining is not really possible. You can mess around with the command line and adding and removing and kind of make it work, but get that set before you build your cluster, not easy to change. The other thing that it will warn you about is you can't have any active VMs when you join the cluster. You can have them, you just got to shut them all down and then join the cluster. Not entirely sure why, but it's just an issue. You can join things from the command line with this little command. You'll need to log in or provide the key when prompted on the command line. But if you do it online, it's pretty simple. Here is just some screenshots of something that had no cluster. So you just click on the Create Cluster, give it a name, and tell it which network to use. And you can have many networks that you've pre-configured, including multiple link networks. Once it whirs around for a while, you'll get this. You can click on that copy button to grab a copy of the key, and then go to your other machines and click Join Cluster. It will ask you the network, and you can paste in that key right here and join the cluster, and off you go. Just a couple of samples of some errors. Here I put in something by name that didn't exist, host name deal, and here's one trying to join that actually had some VMs active at the same time, and you wind up with that error. Once you have built it, and I can probably switch back to the live demo here instead of just the slides for this one, you can see everything going on with the cluster. The wrong keys again. So go to the big one and click on the data center. We can see that what we have is a cluster. We've got nothing offline, 3 online. There's a couple of containers and virtual machines running, and everything is good. We can obviously see all of the machines. If we click on cluster, you can see the IDs here. We can refetch this join information at any time. We're already part of a cluster, so we can't join one. That's about all there is to that. It's relatively straightforward. Let's talk about the high availability. That's probably what a lot of people are really interested in, and it's kind of the neat part about it. A couple of caveats. With high availability, if a node goes down that's running something, that VM or container will automatically migrate to a running node on the cluster. If it's a VM, it will migrate sort of auto-magically, as we saw with the migrate. With the container, you get almost the exact same issue, but it's going to take longer than you think. It takes at least 120 seconds for that action to take place, plus however long it takes for that to boot up. Because unlike the migrate that we did of the VM earlier, where it could grab a snapshot of the RAM and then reload it over here without rebooting, that machine has crashed, and so it didn't have an opportunity to grab that, so it has to reboot the VM, and it's starting from the last workable bit of files that were available in the shared file system. It doesn't have the contents of memory there. So there's some amount of time that it takes for it to figure out and decide that, yes, it's really offline. It wasn't just a momentary network interruption. Everybody cast their vote, and they're like, okay, we've all decided that, the ace magician has fallen out of the loop. We're going to spin this up on the Mac this time. So it takes some amount of time for that. Then it also takes some amount of time to fence off the down machine. And this act of fencing is such that this node can't access those files in the shared block store anymore, because if you ever had two things writing to it at the same time, it's obviously going to be destroyed. And it could be the situation that this still had access to that data network, but was cut off in some other way, or was just a corrupt kernel on the host side, and it was half running, not running. And there's a bunch of timeouts built into that fencing setup, such that it just takes that long to cut someone off from their exclusive access to that. And the only way to change those times is to crack into the source code and rebuild your own version of Proxmox. They have purposely not put any knobs and dials in there, so it doesn't become a foot gun for anyone to just, destroy themselves accidentally with it. But it generally does work. It does require that the VMs are available on all the hosts via a Ceph block store or some sort of replicated block store. So you don't have to use Ceph for this to work. You could use ZFS and set up replication. With replication, it will simply synchronize the data on one machine to the data on the other over that private network. And you can do that, and it works well, because it's going to have to reboot anyway. You're just going to lose a little bit of information. So you're going to replicate on some cycle, 5 minutes, 2 hours, whatever. And so it's going to boot on the other node from whatever the last good replica was, which if you're just got a bunch of little web servers or a very small key value data store or Kafka instance or something like that, it's going to be able to, you can replicate that really quickly on a fast private network, and you're not going to lose but a couple minutes worth of stuff. If it's like your primary file server or your mail server with 100 gig of email on it, you can't synchronize that as fast. You're going to lose more stuff. You might be better off with something like Ceph. Either way, both of them are going to benefit from the fastest possible internal network. Another question that comes up is, what is the smallest high availability setup you can have? And a lot of people would like to have just 2 nodes. That's really all you need, right? You just need A, and it'll fail over to B. As long as either one can handle what was running on all of them, you're good to go. But because of that quorum thing, it's not going to work, right? You have to have more than that. If you have 2 nodes and one goes down, you no longer have a quorum because one is not more than 50% of 2. So let's see if this audio works. Now the audio doesn't work. So just another controversial video clip. 3 is sort of the minimum that you need, but there's a way to get there with sort of a shortcut in that you don't necessarily need 3 high performance things on your multi-gig network, etc. You just need a third node to only participate in that quorum part, only to monitor the other host and make sure they're working. If you have that, you can have a full quorum with one dead node and fail over to your one working node, okay. There's 2 options that you can use to do that. One is to just have a smaller PC, an older PC, whatever you have, an older Mac, something that can just plug into the network. You can load PVE on it. You can join it to the cluster, but don't have it participate in HA, don't have it participate in Ceph, don't put anything on it. All it's doing is running that. And that's easy. There's a fancy GUI. Somebody worked on a Raspberry Pi version of it because it doesn't even have to be Intel. It's not going to run any VMs. So you can use that. And the only problems are, it may use a little more power, it may fail, etc. The other option is to use any other maybe newer or smaller machine of an alternative thing like a Raspberry Pi. You don't have to install the whole PVE. Just install these things. Just install the CoroSync daemon and service device and join it to your HA node manually, and it can participate in the voting and be ready to go and act as a quorum monitor, and you can have just 2 devices. And that's really handy for like a home lab or extremely small business situation. You maybe want to have something like a caching DNS server that you never want to fail. You can have 2 devices, just loop the internet into the internal net onto a cheap switch like this, have a little Raspberry Pi as your third one, and off you go. Some options of what you can do with it. DNS, just mentioned that as Apple people, many of you may be running Homebridge. And if you want to run Homebridge for your HomeKit to enable some non-HomeKit supported devices, nobody likes that when that thing crashes and now you're locked out of the house or literally sitting in the dark because you can't turn your lights on. Well, you can run Homebridge as a LXC or a VM here and know that it will automatically migrate if that host goes down. All kinds of web services, the aforementioned Frigate. Time Machine, I use it for Time Machine, and you have to be sort of careful with the Time Machine and other things because you need a lot of storage for that, and that may not be as cost effective to make that in a Ceph cluster. I have mine using ZFS. I don't necessarily do all the replication. It basically runs on one node, and I don't have it in the high availability setup. If it crashes, okay, I don't back up my laptop until I fix it. It's not mission critical per se, but I know that I can rearrange that as needed. Same thing for file servers. Maybe if it's some mission critical small files, it's cheap enough these days to have something like Ceph power it, but not if it gets very large. And then, there's the MailU, which was the impetus for this entire talk, discussion, and learning about Proxmox. While I could have propped up a bunch of Kubernetes nodes and tried to use the Helm chart version, this seemed like not only the path of least resistance to move what I had, but gave me some other options to use in other stuff. That's about all I have. Do you have anything that you would like to add?
No, I think with 3 minutes left, we should probably see if anybody has any.
So who has any questions about anything? We already answered some midway through, so we may not have as many. No questions?
All righty then.
All right.
This is sort of unrelated, but on the previous slide or two,
Yeah.
you mentioned using Homebridge, which you said was for redundancy and stuff. But have you heard of the Homebridge for controlling or adding your smart devices to Apple Home? And I thought that was funny that they both have the same name, but.
Mm-hmm. Yes, exactly. And, I wonder if at some point the Homebridge will have some native redundancy built in to auto sync to multiple things in the house. but who knows? It's all written in JavaScript, so who knows? All right, well, thanks for coming. Appreciate your time. And
Fill out your the review.
Yeah, fill out the review. If you have any questions about it, I'll be glad to try and answer them. If you have any questions about ZFS, I'll be more likely to answer those.